In question number 18, a point object is placed at a distance of 30 cm from a concave mirror of focal length 20 cm as shown in figure. If the mirror is rotated by 30 degree in clockwise, find the y coordinate of image in centimeter to the nearest integer. For this, first we need to locate the image distance in the situation stated here itself. I would say 1 by v plus 1 by u. It is 1 by u was minus of 30 here, must be equal to minus 1 by 20, or 1 by v would be how much? It is 1 by 10. This one is 1 by 3 minus 1 by 2. It is coming out to be minus 1 divided by 60, or simply v is minus 60. This is the location of the image here. Once whole of this system is rotated by 30 degree about this point, then we know the image will be rotated by how much? By 60 degrees, somewhere here around. So this angle will be 60 degree, and this distance was how much? It was 60 centimeter. So the y coordinate, I would say it will be 60 into sine of 60, that is root 3 by 2. It will come out to be somewhere close to 51.9 centimeter, or effectively I would say it is 52. So for question number 18, our answer is 52. Now let's proceed to question number 19. In question number 19, in the arrangement shown at t is equal to 0, the lift starts moving up with acceleration a is equal to 5 meter per second square, and two blocks are released from rest at the same instant. Find work done by tension in the string in joule on the block B in first 1 second. G to be taken as 10 meter per second square. Let's find the acceleration of these blocks with respect to pulley first. I would say the effective field would be how much? It is G, and since the whole of the system is accelerating in upward direction, so the pseudo effect will be in the downward side. So altogether it will be A of the blocks with respect to pulley. It would be 3 into 15 minus 2 into 15 divided by 5. Altogether it is A of blocks with respect to pulley, that is coming out to be 3 meter per second square in this particular direction. Okay, what about the tension in the string then? This time tension in upward direction T. Here 3 into total effective field was how much? 15 here, and under the effect of these forces it is accelerating in downward direction with how much? 3 meter per second square. So I would say 3 into 15 minus T must be equal to 3 into 3, or T is 36 Newton. Okay, to calculate the work done by the string, we need to figure it out how much is the distance traveled by this particular mass here. So with respect to ground, we need to calculate it. So if I'll be taking the direction in upward to be positive, I would say the lift has actually traveled a distance of 1 by 2 into 5 into 1 whole square, and with respect to pulley it has traveled in downward direction. It is 1 by 2 into 3 into 1 whole square, that is coming out to be 1 meter. So the work done is how much? 36 into 1, altogether it is 36 joule. So our answer here is 36. Now let's proceed to question number 20. In question number 20, a uniform hollow sphere of mass 6 kg and radius 10 cm rolls on the horizontal surface without slipping with velocity v0 to be equal to 4 meter per second as shown. Find the kinetic energy of upper half of the hemispherical part in joules. Let's say the spherical body given to be here of mass m and radius r. So 1/2 part shall have the mass of m by 2. Let's say this is the center of mass of this half. So the moment of inertia about this particular point, I'm writing it down to be I0. We know the moment of inertia of whole of the part about this point, it was how much? It was 2 by 3 mr square. So moment of inertia of 1/2 only about this point, let's say it is I1, it has to be mr square divided by 3. Okay. Now, if the moment of inertia about the center of mass of this half is I0, then I would say I0 plus mass of this much of the portion is m by 2, and this distance was r by 2. it will be r square by 4 must be equal to mr square divided by 3, or I naught will be how much? It will be mr square 1 by 3 minus 1 by 8. That will come out to be 5 mr square divided by 24. This is the moment of inertia of 1/2 about this point. Now we need to find the moment of inertia about this point. So it is IP, it will be moment of inertia about this point, that is 5 by 24 mr square plus m, that is m by 2 here, and this distance is r plus r by 2, 3r by 2. It will be 9r square by 4, or mr square, it is 8 to be taken as common here. This one is 9, and if I'm taking 8 to be common, it will be how much? 5 divided by 3. So altogether it is 32 divided by 3 into 8 mr square. So I about this contact point P, that is coming out to be 4 by 3 mr square. Now the kinetic energy, it will be how much? 1 by 2, I being 4 by 3 mr square into omega square. Omega is V naught divided by R, so it will be V naught square divided by R square. This one will cancel out. Put the values of all these term now. It is 1 by 2 into 4 by 3 here. M was 6 and V naught is 4 into 4. This 6 will cancel out. It is 64 joule. So kinetic energy is this much. 64 is the answer for question number 20. That's the end of this question paper. Hope you must have appreciated the solution, and I wish you all the best for your further preparation. Thank you and goodbye.